All right, let's take a look at taking a skeleton equation like this one and turning it into a sentence that describes the chemical change. The first thing that you should address is the nomenclature. We have 4 substances here, and we need to know the names of these substances before we do anything else. And there's a video on this, so you can go back and watch the nomenclature video if any of this doesn't sound familiar to you. So my first substance, Na3PO4. I know that's an ionic substance because it starts with a metal. It starts with sodium. Another way that I know this is an ionic substance is the 3 capital letters. If it's got 3 capital letters in it, I know it's got to have a polyatomic ion in it, which makes it an ionic compound. To name it, I split it into its positive and negative parts, and I write down the name of each part. The positive part here is sodium. The negative part, PO4, is phosphate. I leave that little space in the middle in case I need to add a Roman numeral to this name. And as a refresher, you need that Roman numeral whenever you cannot look up the oxidation number of your metal. Now, sodium's in group 1 on the periodic table, and group 1 is a very predictable +1 ion. So because of its predictability, because we can actually look that oxidation number up, we do not need a Roman numeral. KOH is my next one, and again, it's ionic. And there's 2 reasons why I know this is ionic. First, it starts with potassium. Potassium is a metal, so the left of the metalloids. The other way I know this is ionic is the 3 capital letters. When you have 3 capital letters, you know there's a polyatomic ion in there, and that makes it an ionic compound. So again, we have a positive and negative part. We have to name those 2 parts. K is potassium, and OH is hydroxide. And again, we leave that little space in there just in case we need a Roman numeral. To figure out whether or not we need the Roman numeral, we have to try to find the oxidation number for potassium. Again, if it's in a predictable group, 1, 2, or 13, then we don't need a Roman numeral. If it's a transition metal, then we probably do. So potassium, we look on our periodic tables in group 1. That makes it a very predictable +1. No Roman numeral in this name either. Now that we're done with this side, most of the work is done. We know that neither one of our metals require a Roman numeral, and that's going to be the same when we deal with these 2 substances on the product side. We know we're not going to need a Roman numeral over there either, so we don't even have to think about it. We also know that our ions are going to be the same on both sides. It's a matter of just switching around the metals, basically. So we have the sodium attached to the hydroxide now. So sodium hydroxide, and we have the potassium attached to the phosphate. Again, in most of these, most of your thinking takes place on the reactant side. Once you get to the product side of the equation, you're just swapping a couple parts of the names around in most cases, at least when it's ionic. So now we know what everything is, we're ready to write our sentence and describe the chemical change. And we just work our way across the sentence. Na3PO4 is sodium phosphate. The plus sign on the reactant side means reacts with. KOH is potassium hydroxide. The arrow means to produce. NaOH is sodium hydroxide. The plus sign on the product side means and K3PO4 is potassium phosphate. So again, what you got to do to turn these equations into sentences is do all your nomenclature, figure out the names of all your substances, and then understand that the plus sign on the reactant side means reacts with, the arrow means to produce, and the plus sign on the product side means and. Remember, we could have our state definition or abbreviations in here. If you see a little S in parentheses, make sure you mention it's a solid. If you see an L in parentheses after one of these formulas, make sure you mention that it's a liquid. If you see a G in parentheses after one of these formulas, make sure you mention it's a gas. And if you see a Q after any of these substances, it's aqueous, which means it's dissolved in water.